Well, let me introduce you to polynomials. We're going to add, subtract, and multiply them as stuff that you have seen before, and a lot of people make this much harder than it is. Please do not. Please do not. Okay, I want to point out the difference in the different types of problems. First of all, this first problem is addition. The second one is subtraction. Third one is subtraction. These are multiplication. How do you know? Because I have something crammed up beside the parentheses of something else. Now, I know there's addition in here and some subtraction here, but it's multiplied together. These are multiplied, two things multiplied. These are multiplied. This is squared, so it's like two things multiplied. Notice the addition or subtraction is not in between the parentheses like it is up here. So that's a different type of problem. So let's just start. When you are adding or subtracting, simply just put your like terms together. Do you see anything that's to the third power other than this one? No. Then he's the only one you get. All right, let's switch. I see something squared. I see something else squared. -6 plus 5 is -1. And it's x squared. Don't change the exponents. I have -6 plus 5 of them, and I still have x squared. Okay? I have 2x plus -2x. If you wanted to waste your time, you could say, well, I have 2 minus 2, so I have 0 x's. Some people would say, oh, well, I don't have to put anything, so it's an understood 1. No, it's 0, because they're gone. And you could just leave that off completely. And then the last piece is this right here, that regular number, just 7, no x's. I don't see any other terms that have just a regular number, so he's the only one, and he is positive. And that's my answer. You can leave the 0x out. That is it. I'm just putting like terms together. So we're going to come over here and do the same thing. However, on this one, we're going to subtract. And what I find to be the most beneficial on this is to say, well, you know what? I think I'm really going to just distribute my negative. And when I distribute my negative, that means that I'm really going to add the opposite. So let's add the opposite of 2. It'd be -2. Add the opposite of negative. So it'd be positive, and add the opposite of positive 1, so -1. Change all the signs, that's all I'm really saying. And now we do the same thing. I have x cubed. I'm looking for other x cubes. There you are. 2 plus -2, or 2 minus 2. I have none of them. I didn't even have to write that. You can mark it out. You could have marked this one out. Okay? I'm looking for x squareds. I see one here, 8 plus 1. 8 plus 1 obviously gives me 9. So plus 9x squared. If I don't have this, I don't have to have that plus. That term kind of means I don't need that positive sign there, but whatever. If I leave it, then I'll need the plus sign. Okay? I'm looking for x's. No variable, no exponent on my x other than an understood 1. So -6x, looking. I see nothing else. That's the only one. It's -6x. Looking for other things I've left out, like this little -1 right here that has no x's on it. -1. Done. We have put our like terms together. This next one is going to take an extra step or two because there's so many things going on here. We have a squared, b squared, ab squared, b squared, a regular number. We have lots of things that could potentially go together that don't. Before I go there, though, let me actually read the directions and finish what I've started. Simplify and state the degree of the resulting polynomial. The degree of this polynomial is the highest exponent you see, which in this case would be 3. So the degree is 3. So if you wanted to be like, oh, well, the degree is 3, that's fine. Now over here you'd say, oh, the degree is also 3. No, this term went away because it was 0. So this is the degree. The highest exponent you see is a 2. So the degree is a 2. Now for this next one, we're going to have a's, b's all mixed in together. So we're not going to talk about the degree. That's a completely different issue, okay? So let's put these together. Here goes. Before we put them together, let's go ahead and say, well, let's add the opposite of all of those. And there's a little room for error here, but if it helps to unclutter things, let's just write it all again. And I really don't need these parentheses. So I'm going to just write it all without the parentheses. Parentheses group things together, but there are times people put parentheses in that you really don't need them. So plus negative 5b squared plus negative 2ab plus positive 3 plus positive 9b squared. And now I'm just going to go through here and find things that are alike. And if it's alike, I'll put them together. And if it's not, I won't. And I'll just leave it. Okay, so I'm going to just go one step at a time. We'll start by underlining things in blue. I have a squared, b squared. The blue and the black look very similar. I'm looking for other a squared, b squared. There's ab, but they're not both squared. Notice when I say this, I'm not noticing the number in the front. I'm ignoring it. There's ab squared, but the a is not squared. There's b squared, no a squared. ab, nothing at all, just a 3. b squared, nope. It's the only one. Final answer is that so far. Let's keep going. 6ab. Looking for ABs. Oh, there's one. Oh, wait, no. This b squared. These are not like terms. Like terms have the same variables and the same exponents on those variables. Coefficients can be different. They often are. So 6ab, there's a b squared. Oh, there's an ab. Negative 2. 6 minus 2 is going to give me 4. AB. All right, let's switch colors. I have negative 3 AB squared. Looking for other AB squareds. Nope. See, B squared, but it never has an A with it. So minus 3 AB squared. Okay. We'll switch back to blue. I'm looking for B squared. I'll make these jaggedy. Oh, there's one. Negative 5 plus 9, that would be 4. And then the only other one that's left, the only other term left is that 3 there that has no A's, no B's, and it's just 3. That's it. What's the degree? Not worth our discussion.